So in this video, I'll be showing you how to perform how to launch TurtleBot 3 simulation in a Gazebo. So for this, we'll be using TurtleBot 3 simulation package for the ROS2, including Gazebo simulation, cartographer, SLAM, and various world models. Later on, we'll also perform autonomous exploration with Explore Lite. So this will be the workspace structure. Prerequisites will be ROS2 Humble, Gazebo 11 Plus, Classic I'm using, TurtleBot 3 Cartographer, ROS, which is given by the Google. You can get all these packages from these listed documentations. Okay, so let's begin. So first of all, what we'll do, we'll launch Gazebo. You can find the launch file for the Gazebo in TurtleBot 3 simulation package. TurtleBot 3 simulation, TurtleBot 3 Gazebo, and TurtleBot 3 small house launch. So I'll be using small house world to launch this file. So in my repo, if you go in the src folder, you can find these data sets of Gazebo worlds and map. So from this, I'll be using uh, small house one. So here TurtleBot 3 Gazebo, TurtleBot 3 Gazebo worlds, small house.jpg. This is how small house looks. So let's perform. So this is the launch file. So make sure you have all necessary things in your bash HRC. Let me show you that what things you need in a first of all TurtleBot 3 model, RMW implementation. This causes sometimes issues, so make sure you have Cyclone TTS installed, and you need to give the Gazebo model path. Sometimes Gazebo models did not load in Gazebo. That's basically due to the classic Gazebo issues. Like you need to create a folder with name in your home directory, Gazebo slash models, user Gazebo setup.sh, and you also need to like this is the path. You need to put all your models there. Gazebo basically picks all your models from there. So also make sure that you source your ROS Humble. Okay, so now let's perform it. Make sure you have sourced all your terminals before launching it. So we'll be launching ROS to launch TurtleBot 3. Let me make it. ROS to launch TurtleBot 3 Gazebo. This is the package name and this is the launch file name. So let's launch this. So Gazebo is launched. So this is how the small house world looks. Okay, so here's our TurtleBot 3. You can zoom it to view this. This is the TurtleBot 3 baffle model. So now we'll be launching the cartographer node, which will help us building the map, and the teleop node. It's optional to launch the. This is ROS to run TurtleBot 3 teleop keyboard. So cartographer command is this: ROS to launch TurtleBot 3 cartographer cartographer.launch.py. Usim is equals to 3. I am picking this from my ROS Humble uh, source opt ROS Humble directory. I installed there. You can also launch them via this, like TurtleBot 3 cartographer TurtleBot 3 launch cartographer.launch.py. This is the custom launch file. You can launch from there. Here also, it's one and only same thing. So this is the ROS2 teleop node. So let's get into the Gazebo. Pick this and let's put this aside. So let's see. If you move your TurtleBot 3, let's say press W. So make it move forward. Like it's moving forward. You can also see this in the Gazebo. Let it come a little forward. Hit the obstacles. Like it's going in this direction. So where's the terminal? So these laser scans actually help uh, building these maps. Like it hit the obstacle. Let me stop and move it backward. You stop it. The max velocity is it's 0.26, so it won't exceed this. You can change all these velocities in the TurtleBot3 file. So we have explored from here, so let's see how much map is built. So this much map it has built. You can also launch nav2 file. It's optional. Cell size. Yeah. So this is the map. This is my robot. You can also check the odometry of this. So now I'll be performing autonomous navigation using this. So let's quit the Zibo. So this is okay. So quit cartographer node. You can also save that map. Like before quitting all these, you can also save that map. Uh, I'll show you how to save that map. Like by using this command, make sure you don't exit from both the terminals. Launch this command to save the map. It will save the map. Add provide path to your map where you want to save your map here. So I'll be showing I have built the map. Let me go to the home folder, and where it is, ps1 yeah, it's here. So in the src you can see this is the map. I built it using this. So it's not perfect because it took a lot of efforts to basically move it via your keyboard. So later on we'll be building a very good map using TurtleBot3 autonomous exploration using using explore light package. So that is for the next video, and in this video I'll be performing autonomous navigation. So let's launch it. So what was the command to launch it? These are basically all the installation things. Like you can clone my repo, you can export these paths, you can source the bash src, make sure you install all the dependencies, you build this package autonomous exploration. Yeah, this is here, it's autonomous navigation. So this is the command: ROS to launch TurtleBot3 navigation 2 navigation2.launch.py. Use sim is equals to true. Provide the path to your map which you want to launch. Okay, so let's launch it. So let's launch gazebo in small house. Let's launch the nav2 stack. So this is the command: ROS to launch TurtleBot3 navigation 2. This is the map path. So let me enter it. So it has launched this. So you need to first provide a 2D pose estimate. Like this is the origin. So I'll provide this as the 2D pose estimate. So you can see this is the local planner and a global planner also. So you can provide a task to it to reach where. Let's say I'm providing it a task to uh, go here. So this basically plans the path, and it started moving in the gazebo also. Like you can see, the better is the map, the better it will performs. Like you can avoid these errors for the RVS plugin docking and rest all plugin errors. Let's provide it a let's reach here. You can also set the odometry by like this. and you can set the odometry via this. We'll plan this. So this is basically now using TurtleBot3 navigation. TurtleBot3 navigation params webfile.yaml. So it's using nav2fn planner currently. We can also use our custom own planner. I'll be showing you later how to launch our own custom planner. I have used Dijkstra's algorithm, which plans the shortest path. Currently, this navfn planner works best. It's a combination of many algorithms. So here it's after building the map, you can give it the command and it will work. So let's quit this. Let's quit this. So it's sufficient for this video. Let's use autonomous exploration in the next video.